This is video 3 for the control systems. In this one, we're going to talk about how to program a remote. Now, the first thing you have to realize is that each thing on the remote has a name. Something you can use when you write your code. So first off, let's talk about the joysticks. Those are the little thumbsticks on your remote. There are 4 channels for those. Channel 1 is your right thumb and it goes left and right. Channel 2 is your right thumb and it goes up and down. Channel 3 is your left thumb, up and down. And channel 4 is your left thumb, left and right. So if you want to call up that part in your code, we want to use this line right here. Lowercase VEX, capital T, RT, and then in square brackets, channel 2, or channel 1, or channel 3, or channel 4, with a capital CH and then the number. So that's the first thing. We have to remember that those joysticks, it's VEX, RT, and then whatever channel it is. The next thing will be the buttons. We have a lot of buttons on this. By your right thumb, we have the 8 cluster. By your left thumb, we have the 7 cluster. With your right index finger, we have the 6 cluster. And with your left index finger, we have the 5 cluster. Each button is clearly labeled on your remote. So looking at the 8 cluster, we see 4 buttons. There's a left, right, up, and down. So if you wish to bring up one of those buttons, it'll be VEX RT and then button 8U. So that would be like if you did button 8U, that would be this button right here. There's 8R, 8L. I'm sorry, U is for up. It'd be this button up here. So that'd be button 8L or 8U. So some other examples. There's an up and down for the 6 and up and down for the 5, but it's just VEX RT followed by square brackets and then whatever button, and then just carefully label it. So we want to write a simple code. To do this, we have to use a loop. And the loop we're going to use will be a while loop. The loop is something that will perform the code over and over and over. The way these codes work is that they just follow the first line of code they see, and they just go down through the list. And it just goes down through the list as quickly as it can. So what we're going to do is we're going to take advantage of that to use a remote control. If you fail to put in a loop, the compiler or the robot will follow the code once and then your remote won't work. We want it to follow the code indefinitely. So here's our main task, and I've already put in the squiggly brackets. So the first thing we want to do is we want to write a while loop. So while 1 double equals 1. The double equal sign means that you're assigning 1 to equal 1. I know it sounds silly, but basically that is a true statement. 1 will forever and always equal 1. So while, really we're saying while true. Now if you want to put some statements in your code, put in 2 backward slashes and then you can give some statements. I highly encourage you to use statements like this in your code, just to help you remember what is what. So again, once you type in 2 backspaces or 2 backslashes, what's going to happen is it'll turn it green, and then you can type whatever you want, and that is not a part of the code. Now we are making a loop, so that means we need new squiggly brackets. And just go ahead and put the pair of squiggly brackets in. That way you're ready to go. All right, now it's time to let's say I'm going to program the joysticks. Motor, let's say I have port 1. We're going to let that equal vex RT, and let's say we just make it channel 2. Then don't forget your semicolon, and then let's say we have another motor on the opposite side. Now something you can do is you can put a negative and what that negative will do is reverses the polarity. So basically what that does is let's say you're moving your thumb up and the robot's moving backwards and you want it to move forwards. You can use a negative sign to take advantage of that. So what we've just done is we've programmed the joystick. But let's say we have a lifting system, or we have something where we want to control it using a button. So for a button, we're going to use another loop. But this time, we're going to use an if loop. So if, and then for an if statement, you want to open up parentheses because this is going to be the condition. So if the vex RT, and let's say button 8U equals 1. So in other words, 1 means it's pressed, 0 means it's not pressed. So if that button is pressed, we'll have some squiggly brackets. So if that is, we want the motor, let's say it's in port 6, to equal some value, -50. So if that button is pressed, we want that motor to turn on at a power of about 50% power. But we also have to tell the computer what to do if that button is not pressed. So we're going to use else. And really, whenever you have an if, you must have an else. These are called if-else statements. Now for the else, all you have to do is just open up your squiggly brackets. And we just set it equal to 0. That way, if the button 8U is pressed, the motor is on. If it's not pressed, and else is just always, if that statement is false, so in other words, if button 8U equals 0, then the motor is turned off. Now, I have not written any wait statements because this is, if you write this, the motor will be on as long as that button is pressed. Once you lift your finger from the button, it'll stop moving. So these are if statements, really if-else statements. So again, how they work is you have if, and then you have a condition. And the condition must be a true or false condition. And if the condition is true, it follows the commands. And then under the else, that's if the statement is false. It follows those commands. But really, that's all you need. So this code right here will work pretty nicely to program your remote. One of the biggest mistakes people make will be with our squiggly brackets, not pairing them up properly. That's why I use indentations. I tab it over that way. Um, just keeps things looking nice and makes it easier to read, and it helps you to keep track of all of your squiggly brackets. Well, that continues, or continues, that concludes the notes for this entire unit.